Hello YouTubers! You've made it to the third video of my how to look ahead in the Friedrich/CFOP method. And in the first two videos I discussed first how to look ahead in the cross to F2L transition. Then I talked about in the second video how to look ahead in the F2L to F2L transition, so from the first F2L to the second F2L and the second F2L to the third F2L. And now I'm going to speak about how to look ahead in the fourth F2L to OLL. So there's a lot of things here that I think people don't realize you can do. Most people think that when they've reached the last OLL or the last F2L, they're kind of done looking ahead. They're like, yes, did all my looking ahead for my solve, I'm good to go. I just sit here, insert this pair, I'm done. This is not true, actually. You should always be thinking when you're solving, and especially for the last layer. It's actually one of the most useful times to look ahead, is when you're going into the last layer. Because if you can eliminate those transition times between observing the OLL and executing the OLL, and observing the PLL and executing the PLL, you can quicken your times greatly. So, the first thing that I think you should always do when you've gotten to your last pair. So we've gotten to this last pair, observed it, right? I should now no longer be looking at it. Again, just as with the cross or just as with the F2L pairs, once you have found your last pair, do not look at your last pair. You should know how to insert it. This is a really simple case here, right? This corner, this edge belong here. I can insert this blindfolded, right? I don't need to look at it. So now that I found it, the first thing I'm always going to do is I'm going to look at edge orientation. So in other words, how many of these edges are properly oriented in the last layer? Because this is going to give me a hint as to what type of OLL is going to come up. You know, if I have one edge oriented here, and in this case, I know since I'm 2 gen here, this is 2 gens referring to 1 gen of movement and 2 gens of movement, I'll never have any less than 1 edge oriented. And you can't have odd numbers, so that means I'm actually going to have 2 edges oriented. So that's really important. Same thing with, like, let's say I had here, if I had an RUR prime insert, if you always have an edge oriented, when you do that, you're still going to have an edge oriented, assuming you're still doing 2 gen. So what you're going to do is, first thing is observe how many edges you have. Then what you're going to do is, as you're pairing this up, so once you've observed that, then you're going to start looking for corner orientation as well. So you kind of want to look at how many corners are oriented. So I'm pairing these two up, okay, and I can already tell you I got 2 edges there. Now you kind of tell you what's coming up here. And now that I've paired it up, actually I guess so that would be specific. Once you paired up your pair, and this pair right here, this is when you're most likely to use it. You want to then look at the corner orientation. Sorry, I didn't mean to confuse you there. You want to observe what corners seem to be oriented while you're doing it. Because again, if you already know which edges are going to be oriented by looking at the edge orientation, then you should also be able to also start to get an idea of how many corners are going to be oriented. So in this case, right here, I see that this corner is oriented and these two are not. And I know this corner is not going to stay up. It's going to go down. So actually I'm going to have all of them misoriented. And you don't necessarily need to know that, but you just kind of want to observe them and track them as they move. So you're going to track the shapes that start to form. Now, while we're here, so this is kind of on inserting the last pair. One easy way to start looking ahead into your OLL. So you first have noticed, right, your edges, and you hopefully have kind of noticed which corners there. That's useful because now you have an idea of what may or may not be open or oriented correctly as you're doing your OLL. But an even more useful way of doing this, so now that you have all that information, you can also start to actually predict your OLL or your PLL. Your OLL. And this is actually a really simple concept, but I don't think people realize it. You need to know, in order to do this, as you're inserting the pair, which edges and corners are and are not affected by your insertion. So in this case, right here, this edge is going to be inserted here, okay? Now, I know there's only 2 types of inserts that, like, besides if you let's say with an algorithm, that in that case you'll have to figure out yourself what it does not affect. But the 2 basic inserts are, in this case, it's just the L prime U L. It's that simple insert that inserts a pair. Okay, this insert never affects any of these pieces. These pieces will stay in the exact same position as they always will. And I always think of it as directly behind the pair is never going to be affected. Okay, So if I did this from the back, I would know that these are never going to be affected because it follows the line of that. This edge, and this corner are not going to be affected at all. So I can kind of get an idea knowing that I'm at least going to have one edge oriented, right? I'm actually going to I know I'm going to have two, and it's not going to get moved. So these two, these right here, because again, it's behind the pair. Not going to be affected, okay? It gives you a hint into it. So that's that one. So the other one is the RUR prime. This is the other basic insert. And this one always does not affect right next to the corner, okay? So if you have this little block that's next to the corner, it is not affected. That's going to stay exactly as it is. If you track it, blue, blue, yellow, yellow, blue, blue, yellow, yellow. Not affected. So if I want to start looking ahead into my OLL, I can kind of start to see what's going on here. Okay, if I had another corner here, it might be even more useful. This is sort of useful in that I know I have an edge oriented. I know that there's not going to be nothing here. And then I could kind of, if you wanted, you could have looked at this and saw what that formed with that. Now I know I have two edges oriented. I can't have an odd number, and this one was already misoriented, so I must have had two edges oriented with this in this L shape right here. So this is just things you can start to do to look ahead into your OLL. Now, the last thing, these are things that I do. There are more ways you could actually predict your OLL if you wanted to. If you wanted to get really specific about it, you could look into what happens and doesn't happen. But I don't think you have enough time, personally. At least I never feel like I have enough time to do that. So instead, I just try and do those two things. I think those are really simple. You check the edge orientation, you check the corner orientation when you get the chance, and when you insert, you look at the blocks that are not affected and try and predict what comes up. Now, the other thing you can do, besides just doing that, is you can actually affect the last layer. So, for instance, if... oh, goodness. Let's say I have this case right here, okay? I have this little block that needs to go here, okay? Now, I know I could, there's two ways to answer this, right? I could just do a U, RU from R prime. And that gives me, okay, this actually gives me a good case, so this is kind of a bad example. But that gives me a line, okay? Let's not think of this in terms of cases as much as what it or not in terms of this particular case, but in general, what it gives you. It gives me a line. Line is kind of nice. A lot of times it can be okay, and sometimes it kind of sucks. So it's not always the best thing to have a line. Now, it is, however, better to have a cross. I think most people agree that the pairs or that the OLLs that have crosses are really good. So if you ever have a block and you see that you have an L in the top left, this is really the only one I use, honestly. If you do a sledgehammer or you do an R prime F R F, it always gives you a cross. Okay, so that's kind of useful to know. If you sledgehammer things in, it will actually preserve this pair. And the use of sledgehammers can also be used to, let's say, avoid a dot. So if you had, let's say, something like this. If you had something like this and you saw, as you were inserting this pair, that no edges were oriented, and you knew that because it was 2gen, you can't orient edges or you can't affect the state of edges, so you know that you're going to have a dot, and that sucks, right? So what you want to do is you can actually sledgehammer. If you sledgehammer it, look, I don't have a dot, and I have a nice little P shape, which is really nice, okay? So P is, or the L is better than that. So you can actually affect the last layer. So that's one way to do it. Another thing you can do is, let's say, that's another way to avoid a dot. Let's say you have the RUR prime. So those two were with having a block formed. Let's say instead that you don't have a block formed, but you're going to have to do something like an RUR prime, okay? Well, you know, again, that because it's 2gen, right, you're not actually going to flip any edges here because you have a dot. So instead what you can do is you can form the pair. So instead of doing this and putting the pair in, or you pouring the pair in, you can move the pair out like that and then sledgehammer it in. Does that make sense? So let's go over here. I can actually form the pair and sledgehammer it in. Now, this is really useful for those of you who don't know full PLL or OLL. Let's say those of you who use 2-look OLL. This is a really easy way to avoid those dot cases that you hate. So the last thing that I often do, and I think a lot of people do, is if you observe, so let's go through the steps. If we observe that we have edges oriented, and we kind of observe the corner orientation, We can also then, assuming we have a pair, we can also then, if we have all edges oriented, predict our OLL and actually sometimes skip it. So these are little things like Winters variation, if you've heard of that. This in particular is a Winters variation case, and this is actually a really easy Winters variation case because really all you have to do for this case, I look at the corner orientation here, and I'll see I have one corner and these two right here. Kind of looks like the bug eye double triangle thingy. I actually know that all I have to do is do an RU prime R prime, and I'll have a soon back here that I can do. But so you can actually start to predict PLL as well, especially when you have let's say when you have edges oriented. There's also another thing called Magic 1D-Full, which was done by Jeremy Fleischman, which is when you have two edges oriented and you have a block in the back. So like this right here. You have this block in the back here, and this is actually called the stealth bomber. I didn't realize I was going to set that up, but this is actually really useful. You just put it in, and then you have this winter case, which is pretty easy. And a lot of times those will save you moves, so that's kind of useful. Another thing that a lot of people will do, now I don't know that I recommend using these, but there are other things like VH-F2L, Van Vars Landerberg, or what, I can't remember how to say his name, but he basically will make sure that all the edges are oriented for him before he inserts the pair. So again, let's say we're going to get a dot, and you had right here, there is a very particular algorithm that will always make sure that once you insert, I think it's that, something like this. I mean, this is just partial edge control right here that I use to get there. But I know that if I do that, when I insert the pair, I always have edges oriented. I won't always necessarily get an OLL skip, but you can always also make sure the edges are oriented, or all of them are oriented. These are more beginner methods, but these are all just things you can do to look ahead. So you're on your last pair, you observe all the edges, you do these things. You also can influence it, is basically what I'm trying to say here. So yeah, those are a couple of things that I think are really useful.